Yeah. So today we are going to see about a topic, so which is the very important topic, and we can say it is a very basic for the physics part. Okay. So today the topic which we are going to see is, which is very much tied to us like a human beings in our day-to-day life. So without this, it is impossible. Nowadays we can use the word like it is impossible to survive, or it is impossible to complete one complete day. So yes, of course, the topic which we are going to see is electricity. Right from the mobile phones which we are using, and the fans, the light, or the mixer grinders, the washing machines, the refrigerators, everything we are using for our modern life. And if you are saying like if you want to go for a digital one, an electronics one, we need electricity, and this electricity is the basic for our lives. So now actually this word electricity is of two words we call electric and city. It's called electric and city. So the word electric, which represents the electrons, and the word city, of course, it is for a larger area. We call a developed or a larger area, we call it as a city. And if the electrons which is moving in a larger area, that is we call electricity. Also, this electricity is given by different names. For example, we can say it as current electricity or electric current. So both electric current and current electricity both are the same, but instead of using electricity, we are using nowadays these two terms like current electricity or electricity. Of course, we call it as a power also. We say there is no power, there is no current, but actually we should not use the word current. And we have to use either it is current electricity or electric current, or simply we can say that it is electricity. Why? The reason behind this is the word current in English represents, or it used to denote, current means at present and electricity means, as we know, it is electrons flowing in a larger area. And if the electrons are flowing in a larger area, that is we call as current electricity, or else we call electric current, which means electrons at present, how much it is flowing, that is we call as the electric current. And this electric current is represented by a symbol I, or simply we can use a formula like electric current is equal to charge moving per unit time, or electric current is used to represent number of electrons. So here the word charge represents the electron. As we know, electron is a negatively charged particle. So if a number of charges moving in a given time, then we call that as an electric current. So it is represented by a symbol. Electric current is I, charge is represented by Q, and time is represented by T. So the equation which is used to represent electric current is I is equal to Q by T. And now, as we know, Q represents charge and T represents time. To know the unit for electric current, so there is a unit for everything which is used to represent that particular quantity. Here electric current is one of the fundamental quantities. Among the 7 fundamental quantities, electric current is just one of the fundamental quantity. So this electric current is represented by the unit. As we know, the SI unit of charge is coulomb. So I is equal to C, and time is second, or we can use it as coulomb per second, or we can simply say it is ampere. It is represented by the symbol capital A. So we are using ampere. So because the person ampere have given more important like derivations and more important concepts of electric current. That is why in order to give a name, so we are using ampere as the SI unit of electric current. Okay, now for example, if I have a conductor, for example I have an iron rod, and this iron rod is made up of number of atoms. As we know that it is a solid, so here the regular arrangement of atoms means there is no interspace between each atoms. They are very closely arranged. So when the electrons from one atom jumps to the another, like this, electrons when started jumping from one to the another, then we say that current is flowing or charge is flowing. when the electrons is jumping from one to the another in a particular, so this conductor is having a particular length and it's having a particular time. So the time taken by an electron from the first atom to jump to the last atom is represented as the electric current. So this is what the concept behind the electric current. Okay. Now next there will be one more question. Who is making these electrons to move from one to the another? Or is there any other force required to make the electrons to move from one to the other? Of course we need a force, and that force is called as the external force. And before going into this external force or what makes the electrons to move from one to the another, we should know one more thing. Why we are saying like only electrons is responsible for the movement of current, or movement of electrons is called as current? What about the protons or what about the neutrons? Why if a proton moves from one to the another will it be called as electric current? And why particularly we are using only electrons to represent electric current? Yes, this question is because as we know that electrons is present in the outermost of a nucleus, and we know that nucleus consists of protons and neutrons. Here proton is represented by a positive charge, electron is represented by a negative charge, and neutron is a neutral, it is chargeless. So these electrons which are present near to the nucleus get very tightly attracted because electron is a negative charge, proton is a positive charge, so they will be attracted. As the distance increases, the outermost electrons, the shells, the outermost electrons are shells, or they are very loosely bounded to the nucleus, so they are called as the free electrons. And these free electrons are responsible for the flow of electric current. So when these electrons, like even a small force is applied to an atom, these electrons will jump out. And this electron is responsible for the flow of electric current. So this is one side. Now coming to the force. So what makes the electrons to move from one into the another? Now for this again we are taking a conductor. So here the atoms are regularly arranged. So as we want to say that electric current is flowing in the circuit. So this conductor now I am connecting to a battery. As we know that the longer line represents the positive end and the smaller end represents the negative, and here we are keeping a key which is used to on and off. So now the key is on. So the positive current flows in this direction and it comes away like this. So current always travels from the positive come to the negative. Now if I have a battery here, so this battery will now act as an external source which pushes the external electron, the outermost electron, to jump from one to the other, which is completely, it is like continuously pushing the electrons to move from one to the another, and hence it is completed. Okay, this is a simple thing. Now what makes this battery to supply the force? For this we call this as a word potential difference, or it is called as the electric potential. As we know that potential is a word which is used to represent the ability. So electric potential means the ability of the electrons, or how much, that is the work done. So we know work done is equal to force into displacement. And here what work is done? The work is done to move an electron from one to the another. For that we are applying a force. So force applied, electron moved, so work is done. And where this work is done? The work is done on the charge. So for this we are using a formula V, that is equal to W by Q, where V represents the electric potential or potential difference, W represents the amount of work done, and Q represents the charge. Work is done to move a charge. That is we call as the electric potential. And this electric potential is represented by V, and here we have a unit. Next we are going to see about what is the unit for electric potential. So the unit of electric potential V is equal to, as we know, work done is represented by the unit joule, and Q is the charge which is represented by coulomb. That is joule by coulomb, or it is joule per coulomb, or it is simply called as volt, which is represented by V. Actually we should use small v. Volt because it's the name of a scientist, Alexandra Volt. Okay, now we are talking about electric potential, but I didn't say anything about potential difference. So electric potential and potential difference, as I said, that they both are relative terms. We can use either electric potential or potential difference. So is there any other relation, or we can define electric potential and potential difference in different way? Of course, it means electric potential is the amount of work done in moving a unit charge from infinity to a given point, or else it is the amount of work done in moving a charge from one point to the another. But in the other hand, we have the potential difference. As the word it is their difference, and we know potential variability difference, higher to the lower. For example, we can say like if we want to pump a water. Like normally in every houses we have the water tank at the top of the building, and the well or the source of water is always at the bottom. So we have to pump the water from the bottom to the top. For that we are using an electric motor. So electric motor pumps the water from the bottom to the top. But after pumping, like the tank is filled, just we are switching off the motor, and just if you want to open the tap, if we open the tap, for that the water should come from the top to the bottom. For this we doesn't need any kind of external sources. Just if I open the tap, the water automatically starts to come from the top to bottom, which means electric, that is a kind of electric potential, higher to the lower. The same way electrons always flows from the higher potential to the lower potential, that is called potential difference, which means again it is the amount of work done in moving a charge from a higher potential to the lower potential. In both the cases, one similarity is that both there is a work done in moving a charge. This is from one point to the another, and this is from the higher potential to the lower potential. So force applied, electron starts to move from one point to the another, and hence current starts to flow. So this is we call current electricity or electric current. And this is not a simple topic. This current electricity is a very vast branch in physics which has a various applications, and depending upon the number of usages and depending upon how we are going to use, this branch is further divided into so many sub branches. So that we will see in the next classes.